Hello, this is the second part of the video where I show you how I develop my single page applications. In this second part, I'm going to focus on the router. So here's my router definition. As I told you in the first video, I'm using my own custom-made router which integrates with the RxJS. It's developed in pure TDD and it works great in memory. So you have this create browser router. You could also, if you're developing something like a non-web application, use a create memory router. It's the same API and it has exactly the same behavior. It will just not require URLs. So in this case, I'm using a browser, and you need to provide a history from the history library, which is great in our case because history can be either a browser history or a memory history. And you provide this history and the root definitions. Here I'm gonna have this home root. This is like, sorry, I need to start the application. So this is my home root. It will be, it will have whatever you can provide or not. The last slash doesn't matter. And the beer roots. So the thing is, the router is really a tree. Like, you can represent navigation using a tree structure, and basically navigation, intuitively, it's a tree. Like, you can either be in the home branch or the beer branch, and if you're in the search sub branch of beer, then you're also in beer. So I've tried to make it the most intuitive, and because the human brain is really good at reasoning about navigation, like if I'm here, then I'm also here, but I'm not here. And it has to be clear that it's like you cannot be in two places at the same time. You can think of it like this is the country level. You're in the home country or in beer country. You cannot be in both countries at the same time. And this is the city level. Search is a city inside the beer country. So if you're in home and you want to go to search beer, you first leave home, then enter beer, then enter search. And that's exactly the order in which the events will trigger. And you can give a path to your routes, and really you should think of the path as an implementation detail. Like they're declarative. They will be used to display to construct the URLs, but they're not the core abstraction. The core abstraction is really the routes themselves. And so here in this case, it's a very simple application. You only have three leaf roots, so it makes sense to put everything in the same place. But if you have a bigger application, and usually that's what I do, I put the root definitions in the page folder themselves. Like maybe we could have we could have the root file, root definition file at each level. Like you could have one in the beer folder, and you could have one in the search folder, you could have one in the detail folder. So this is to present you very quickly this router implementation, and you well you I'm it's a very new project, so it might change in the future, although I've unit tested it quite thoroughly, but it's not documented yet, so we'll see what happens with this project in the future. What I find important to tell you about is that this router, the routing is part of the core, the application core, and I put it in the application core folder. And when you think about it, well, after a few months using this router in my applications, um, I've come to think that the router and the stores are really like two pieces of the same thing. So maybe in the future, it could be a good idea to merge them in this, to merge the routing into the stores, or we'll see. Maybe if you have some ideas, I'd be happy to hear about it. So here my my core is really a router, a store, and a tree of like a tree that mimics the pages and the navigation, and with the focused stores on each leaf. So this is the home page. It does absolutely nothing except one thing. It provides a link. Let's go to this home page. I'm talking about pages, but everyone by now, I guess, has understood that they are conceptual pages. They're of course not pages in the classical term. They are all part of the same single page application. Basically, a page is like a component which has a path. Well, in my own dialect. So here, that's my home. It's a root, which this is my own custom component. It's a bit complex. Don't really care. Please don't mind about it right now. It's just to say that, okay, I want this component to display when I'm matching this route, the home route, from the router. Maybe I'll just show you something. The router gives you well, I'm just going to open it to the side. Here. Here I'm defining routes, and the router will dynamically create this tree structure. So here we have beer, and nested inside of beer we have search and detail. So I can have beer and then search or detail. And at each and every level of the router you have a state, but really what you're going to use is the match. Match is an observable, so you can subscribe on the match, and match will be either null if you're not matching, and if it's matching it will give you a boolean which is exact. Exact will tell you if you're exactly matching the root or not, and this is here where we want to match exactly this root. Otherwise we don't show the component. And in case you have params for like detail, it will also give you those params. And here you have params, and there's only one param, it's beer ID, and the type is always string. So you can reactively handle these navigation events, saying, okay, when I'm matching this route, I want to do something specific. We'll do that later, but right now we're just looking at another feature of the router. The router is type safe, and the URLs are really an implementation detail, but I still provide a path for each route. So here, if you need the path for this beer search, you just ask the router for it, and you have it. And that gives us here. Let's close this. This link it has a path given by the router. So when I click it, I get to the correct URL. Then, so this works as we've seen, and we want to make this clickable, and we want to programmatically navigate to the beer detail page when we click here. Let's do that. Beer search, beer list. So we want to make it clickable. Click with the beer. Let's say your ID will be the ID, and it will return function and beer detail. Oops. Push is to navigate programmatically, and push here will require you to enter the params that I specified in the root definition, so that here you are guaranteed to not forget the params. BRID. Okay, good. And I'm going to beer click of beer.id. Okay, and here we are. Here we clicked on the beer and we navigated on this URL with the beer ID. If we come back and click on a different one, we'll have another ID, etc. So now that we're on this page, the beer detail page, I want to start writing tests, and that would be tests that begin with, okay, when I enter this beer detail page, I want to load the beers. And like I have this boilerplate here. So really, again, think about what's the abstraction level of the user. That's where that's the level you want to write your tests. And the like entering the beer detail page, you can come from a link, or you can come directly like from a URL, and you want to have the same behavior. So really the use case starts with this event. I'm getting inside, I'm entering this page. So that's what we're going to write. Describe when entered the beer detail page. I usually don't write this part because it's quite obvious. And before each, it will be quite simple. Okay, we need to get the router. And this router type, it's the type that's inferred from this create router function. Dot beer dot detail dot push, and we're going to need a beer ID. It's a string, I guess. Yes. Okay, that's where it starts. So and when we're getting in here, we're going to start fetching. Although I like to have a little spinner or a message or something that is shown when you're waiting for for the result to appear. For example, in this page, uh, it's kind of lame to get to this page and just display nothing, and the user doesn't know that there's actually something happening behind the scenes. It's good to give him feedback, to give him a little message or a spinner or something to tell him to just wait, and results will come shortly after. So I'm going to do that same pending stuff we had before. I'll put it to true because I want to test it. So even before No, it's okay. Like when we enter, it is pending, and that would be store expect store dot current state pending to be true. Actually, before I even do that, I want to make sure that before I enter, the pending is false. Why would I want to do that? No, actually, I don't care. That's not really... No, I don't care about that. Okay. You realize I change my mind all the time. This is one of the reasons I make sure that my tests are not dependent on implementation details, but because I change my mind all the time. It takes me 3 or 4 tries before I get the solution I want. So, and I don't want my tests to break in the meantime. Okay, I want it to be pending when I enter my page. So basically, I'm gonna put it to false initially, so that my test breaks. And here, my create beer detail store, I want to focus on beer detail. Okay. Beer detail store. Yeah, okay. I need to initialize. Okay, here expected true, got false. So just initially, no, that's good. Keep it to false. So here is the moment I want to listen to the router and tell the router, okay, when I enter this page, I want to do something. Here I'm going to change a bit the code. And I want to, yeah, basically listen to the router. So router dot beer dot detail dot match dot pipe. I want to filter. I want to filter because I only want positive matches. I don't care when we leave the page. I only care when we enter the page. So boolean, that will filter out the negative matches, and subscribe to the match. What will happen? Well, I guess we'll just dispatch an event. What event can we dispatch? We first have to give the type for that event. That will be on beer detail enter. And we need the BR ID. So that will be beer ID. So store.dispatch match.params.beerid. And one problem here is that the okay, here it works. It's going to work, but I'll show you the problem later. So we have to do something when that action is dispatched. And what are we going to do? Well, for now we'll just set pending to true. Okay, now we're good. In our component, I want to show that pending state. There's a reason for that. You'll see very fast. Component from stream. I want my store. I want to pick pending, then I want to pipe map my state, and here I'll destructure my state and end the in the content I'll have a conditional. Pending. If it's pending, then I'll show please wait. Otherwise, I'll show the beer name. So okay, luckily this works for us, but in some cases I've had problems with this this behavior, and like subscribing to this router doesn't work perfectly all the time. So I have this onload method that will make sure that the page is correctly loaded, that everything is rendered before you start listening to this kind of events. Until I figure out how to do a better thing, I suggest you use that. Okay, so now we're waiting for something to happen. We're waiting for what? Well, we're waiting for a response to arrive, but we should first make sure that we made the request, and we made the request with the correct value. So it's pending. When we enter, we want to be pending, and we want to make sure that we made the request. It fetches beer details. Expect the beer service, but we don't have the beer service reference, so let's add it. Expect the beer service dot fetch beer to have been called once with exactly the beer ID. And again, we need to initialize this fetch beer with a stub. And okay, expected stub to have been called exactly once, so we have to call it. And that would be using an epic. So let's pipe this thing. It will be a switch map. Let's extract the beer service dependency. Fetch beer ID. A beer detail. And we need another action. Beer received. Okay, we'll just call it beer here. And on beer received, that would be the beer. Okay. And again, never, when you stub a dependency that should return an observable, always make it return something, some observable. Returns never is great. Okay, good. Now it's been called. And let's check on in our browser. If I enter, yes, I do make this call, this API call. That's good. Now we've entered, we've made the call. Now we're going to handle the response. When received beer, it will be before each. So we're going to make the exact same thing we did with the other page, with the beer search page. Will not return never. Instead, we'll return the stub will return a subject, and then we can just add stuff to the subject, and that will simulate the fact that something returns. Received So received, maybe we should okay, next, in a beer. Well, I just use empty objects here because we don't care what's inside the beer. We'll just check that the reference is the same in the end. So we've received the beer, then we want to test that it is not pending anymore. Expect to be false, and that would be an update on beer received, beer set field pending false. Great, that's one test that passes. And it stores beer. Yes, beer is okay for me. That would be beer So here I'm going to use an optional, can be defined or not. So it's beer to equal beer. So expected undefined to equal my beer. So we'll just have to store it. Okay, good. So looks like it's working at the component level. We first wait, then we receive. So now we need to extract that beer, pick that beer data from the store and use it. So if I'm what happens? See here, beer can be undefined. So what we should really, if you want to think at the compiler level, well, actually, beer and beer.name. So if we have a beer, we display its name. Here, yes, that object is possibly undefined. We know that we should either be in the pending state or have a beer, but we cannot provide any guarantee at the compiler level. So, okay. And then I'll just enrich this a little bit. With just show the beer details, and we'll stop here because that's enough. Okay, please wait, and then we have all the details. And if we change the ID, put 3, and then we can navigate with the browser. Beer 2, beer 3. Okay, seems like it's working. Okay, this is a very simple example of how I do things, how I use the router in my unit tests. But you can do really complex stuff, and the ability to programmatically um, navigate in your unit tests and have your router really integrated in the test-driven development process is really great, because then you can use that router to orchestrate all the complex and usually fragile stuff, and that will save you a lot of headache. Um, and please never use those component lifecycle methods if you're using React to start fetching data, because then there will be no way for you to unit test your code, unless you're using more advanced techniques, which I'm not using because they're more complex and slow. But really keep it simple. Have this have this router. It's really the navigation, the routing are first-class citizens in your single-page application. So they're quite central in what you'll be doing. So keep put them in your tests. I think that's pretty much all. I've covered the whole idea, and well, if you have any questions, you can always reach me, and either on GitHub or on Twitter, and I'll be happy to answer any questions and help you if you need. Well, thanks for watching. Have a great day. Bye.